Now let us start from where we have just left out. I was just talking about the stopping potential, the variation of stopping potential with frequency. And I have just made use of one fact that the incident photon, energy of the incident photon is used for two purposes. Let E be the energy of incident photon. This is used for two purposes. One is for providing work function, and I will write work function by phi and not by h. The work function is written by h, so this E will be phi naught plus kinetic energy of electron. Now kinetic energy for electron, I will use the formula of mechanics I mv square. Now we know that energy of photon is just h nu. So I will fill here h nu is equal to phi plus half mv square. Now if v is equal to 0, that is velocity is equal to 0, we take phi as phi naught and nu as nu naught. So I will use these values in equation number 1. So it means I shall be having h nu naught is equal to phi naught plus 0. This is the sign of equality, and let me make a bit of the correction here. So this is equal to this. This implies that this h nu naught is equal to phi naught. I have put this equation number 2. If I use this equation here, then we get, here I will have to erase it now. Previously I have just given you a bit of explanation. Here I shall be giving you complete explanation here. So one should be a bit of familiar with the equation of straight line intercept form, which is not that tough. And now this h nu naught plus half mv square. Now this represents kinetic energy. So kinetic energy, this is maximum kinetic energy at a particular point. This is maximum kinetic energy. So this maximum kinetic energy, I can just write this equation h nu is equal to h nu naught plus k max. Now k max, all of us know K max is EVS. So if I fill this value, I will get plus EVS. Now from here, I will calculate the value of EVS. This will be h nu minus, this is work function. So I will write work function phi naught for it. And from here we can get the value of Vs, which is h by E into frequency minus phi naught by E. So this is its value. Vs is h by E into nu minus phi naught by E. Now, this is the slope, and this part is intercept. So I will just write M is the slope h by e, and c is intercept minus phi naught by e. Now, many times MCQs and questions in CBSE board have been asked on the basis of this graph. This graph is very important, and that's why I have just elaborated it. Now, remember one thing. I have drawn this graph between stopping potential Vs. If stopping potential Vs is along the y-axis, then here, this is the angle theta. I will take it as angle theta 2, and this as angle theta 1. And then slope of this line will give us h by e. Slope of this curve gives us h by e. If this theta is given, I can find out the slope m1 is equal to tangent theta, and this is equal to h by e. In case of stopping potential, so the slope of these lines is constant whether it is for energy E1 or for energy E2. Slope is constant for this graph. This is for theta 1. This is h by e. And now this is the value of the intercept, minus phi naught by e. Minus phi naught e is the value of intercept. From here I can calculate work function. If this part is given and I multiply it by, you can say, just e, then I will get the work function. So this is work function divided by electronic charge. Work function divided by electronic charge. So we should be quite aware of this fact if we are given a graph like this. Now this is particular case of stopping potential, and I emphasize this stopping potential. If we take this case, this particular case, this is K max. This is K max or kinetic energy. If we draw graph between kinetic energy and frequency, then slope gives us Planck's constant and intercept gives us what? Work function. So in our next diagrams, we shall be having a diagram like this, where we shall be given graph will be between kinetic energy and frequency. Here the graph is between stopping potential and frequency. If the graph is between stopping potential and frequency, then slope gives us h by e and intercept gives us phi naught by e. Phi naught is work function. If we multiply intercept by electronic charge, then we get work function in case of graph between stopping potential and frequency. Now second case. Second is this case. This particular case, and I am highlighting this equation now. In this case, the graph is between kinetic energy and frequency nu. If this is the situation, then slope will give us Planck's constant and intercept will give us work function. In which case, in that case in which along y-axis we have got kinetic energy. So, summing up in two sentences, in graph between kinetic energy and frequency, intercept gives us work function. This is intercept. This length is intercept here in first diagram. For metal A. For metal B, this is the intercept for metal B. So intercept gives us work function. In second case, if the graph is between stopping potential and frequency, then intercept gives us work function divided by electronic charge. So now I will conclude all this experimental study. Now, the very first part that we get from this experimental study is there exists a certain minimum cutoff frequency which is the stopping potential for which stopping potential is zero. That is minimum value of frequency of incident radiation below which photoelectric emission stops altogether. मतलब कि there exists a minimum frequency if a photon of frequency lesser than that is incident. And let me write it here. What he says, if there exists threshold frequency, I will write that by nu t. Nu t represent threshold frequency. Now, if incident frequency nu I is greater than threshold frequency nu t, then photoelectric effect takes place. And second case, greater than equal to. If incident frequency is less than threshold frequency nu t, in that case, photoelectric effect does not exist or does not take place. Does not take place has been represented by this cross. Again listen. If the incident frequency of light is more than threshold frequency, photoelectric effect takes place. If the incident frequency is lesser than threshold frequency, then photoelectric effect does not take place. Now, for two different metals A and B, the graphs are parallel straight lines. See this. Graphs are parallel straight lines. Graphs are parallel straight lines. They have same slope, but the threshold frequency is different for different metals. From where? For example, for this metal, threshold frequency is nu O1. For this is nu O2. So threshold frequency for different metal is different. But slope is same. Next point. The maximum kinetic energy of photoelectrons increases linearly with frequency of incident radiation, but is independent of intensity. Maximum kinetic energy is independent of intensity. So I will write it in mathematical sense with K M. I will write here. Km Km does not depend upon intensity. I will have to enlarge it. Here, for making you things clear. Now, This Km does not depend upon intensity I, but maximum kinetic energy is function of what frequency? Km, maximum kinetic energy, is function of frequency. Maximum kinetic energy is independent of intensity. For frequency nu of incident radiation less than threshold frequency, no photoelectric emission takes place. This I have already stated here. If incident frequency less than threshold frequency, then no photoelectric effect takes place. I will write it again. If nu I, incident frequency, is less than nu T, no photoelectric effect takes place. Photoelectric effect does not take place in that case. Now, whatever may be the value of intensity, it's a very important case. It opposes classical mechanics. Once the frequency of incident light exceeds threshold frequency, photoelectric emission starts instantaneously. This is very important line again. Photoelectric process is instantaneous process. Photoelectric effect is instantaneous process, and there is threshold frequency or minimum frequency. This has been represented by nu naught. There is a concept of threshold frequency. Frequency less than threshold frequency, no photoelectric effect takes place. If frequency is larger than threshold frequency, photoelectric effect takes place. It is instantaneous. About 90% of the electrons are emitted within 1 nanosecond. And another important cutoff frequency or maximum kinetic energy is independent of intensity and depends upon frequency or varies with frequency linearly. So we can see it from other graphs as well. So for this I will locate graph from here. Yes, this is Kmax. This is graph for Kmax. As frequency increases, Kmax increases. I want to show you some other graph. So graph is somehow missing here. So you just remember that if Vs or stopping potential or maximum kinetic energy of electron increases with increase in frequency, or if stopping potential it means stopping potential increases with increase in frequency. So up to this point we have just covered the experimental study or the conclusion from the experimental study. Which experimental study? For experimental study we have got this apparatus: cathode, anode, source of light, electrons are emitted, current, photocurrent is measured by a microammeter, and we can vary the value of potential difference between cathode and anode by making use of potential divider arrangement. And now in my next part, after just going through photoelectric laws, laws of photoelectric emission, I will finish this lecture. So for a given metal and incident frequency above the threshold frequency, photocurrent is directly proportional to intensity of light. Photocurrent is directly proportional to intensity of light. I will just write this as small I is directly proportional to capital I. Capital I represents intensity, small I photocurrent. And there exists minimum cutoff frequency for a given photosensitive material. The frequency is called threshold frequency. Frequency less than threshold frequency, no photoelectrons are emitted, even whatsoever may be the value of intensity. So intensity starts working only if the incident frequency is larger than the threshold frequency nu naught. Now I have represented it by nu naught. Previously I was representing it by nu t. So nu naught or nu t is the threshold frequency. And this is the second law. Now I shall be going through the third law. What is the third law? Third law is the frequency for more than threshold frequency, stopping potential or the maximum kinetic energy of photoelectron is directly proportional to frequency of incident radiation. We have already observed this in experiment. Km is directly proportional to frequency of incident radiation provided nu I is greater than threshold frequency nu naught. The photoelectric emission is an instantaneous process. It's an instantaneous process that as soon as the incident light falls on the photosensitive material, electrons are emitted within nanoseconds. So with this, laws of photoelectric emission are complete, and complete is our lecture. And before stopping my voice, I will request you all to go through this video. If you like it, kindly share it. If you don't like it, kindly tell us, kindly comment so that we can remove our negative points or the weaknesses. Thank you. Thank you.